Alright, so we've been looking at graphing parabolas or quadratic functions. And we spent a lot of time earlier this week looking at the shifts and stretches of the graph, vertical shift, horizontal shift, that sort of thing. And we looked at something called the vertex formula for a quadratic function. And we looked at how to graph a quadratic function using that. Now we're going to look at a different type of quadratic function. It's still the same, they're equivalent in the fact that you can turn one into the other. A vertex form can become a standard form. And in fact, the last example that we looked at, we did just that. This is an example from my previous video where we took a vertex form and expanded it out and turned it into a standard form. Okay, which is the ax squared plus bx plus c. And so we're going to look today at some of the standard form graphs, or graphs from standard form. And so to do that, we need to find each of the following items. The vertex, we need to determine whether it opens up or down. Find the axis of symmetry, the x-intercept or intercepts, because we could have 0, 1, or 2. The y-intercept, the point symmetric to the y-intercept, the domain, and the range. So all these things we need to find for a quadratic in standard form. Okay. Now the formulas are going to be different. The techniques are somewhat the same. Some of them are going to be a little bit different though. And so just based upon our knowledge of functions in general and a little bit of what we did with the vertex form, I'm going to look down this list and try to find things that I know I can identify quickly. The first thing I know I can identify is the y-intercept. The reason that's true, the reason I can identify that one pretty quickly, is because for any function, it doesn't have to just be quadratic, in order to find the y-intercept, you simply plug a 0 in for x. You find f of 0. In this case, you get 0 squared minus 2 times 0 minus 3. The 0 squared, the 2 times 0 disappear. They add up to 0. And all you're left with is that minus 3 hanging out on the end. Okay? So our y-intercept is going to be 0, negative 3. Now what's interesting is that in general, the c value, the constant in the quadratic function, is going to be the y-intercept. Okay? So maybe I'll put that in here in a different color. We'll go green on this one. In general, the y-intercept is 0, c, right? The c being from the a, b, c in the standard form. Okay. So now I can't do the vertex. I don't really have any way of identifying the vertex from this equation just yet. We'll come up with one as we go here. I can do opening up or down. That one, remember, the value of a, which was the leading coefficient, will determine whether it opens up or down, and it's just the sign. Okay, so this is a positive value because it has a 1, positive 1 leading coefficient. So we're going to say that the graph opens up because a equals 1, which is positive. Okay. Okay. So I've got the y-intercept. I know that it opens up. I can't do the vertex, I said. I also can't do the axis of symmetry until I know the vertex, because the axis of symmetry will run through the vertex. I also can't do the point symmetric to the y-intercept because I need the axis of symmetry to determine how far away the symmetrical point will be. The domain is easy. We'll get to the domain and range at the end. So x-intercepts the only other thing that I can really work with right now. So let's deal with the x-intercepts first, or next. Okay, so for the x-intercept, or intercepts, depends on how many we have. And this is true in any type of function, just like for the y-intercept. The x-intercept is found by simply plugging a 0 in for the y value, or the output. So we use 0 equals x squared minus 2x minus 3. Well, here's where our solving skills will come into play. This is a quadratic equation, and we talked about, I don't know, maybe a section ago or 2 sections ago, that there are 4 ways now that we can solve a quadratic equation. Okay, you can use the factoring idea, the square root property, completing the square, and the quadratic formula. And any of those 4 methods will work here. As I look at this polynomial, I see that it is factorable, and so I'm going to use the factors to solve this. Okay, so I'm going to use the factoring technique, even though we could do completing the square or the quadratic formula here. So factors of -3 that add up to -2 are -3 and +1. So my factors are going to be x minus 3 and x plus 1. Of course, I take each of those factors, set them individually equal to 0, and my 2 x-intercepts are going to become 3 and -1. Okay, so we have 3, 0, -1, 0. Those are 2 more points on the graph. So we now know that this has 2 x-intercepts rather than 1 or none. What is interesting about the x-intercepts is that they are symmetric to each other. Okay, anytime you have x-intercepts, they're going to be equal distance on either side of the axis of symmetry, which is a very, very nice feature. If I just plot out the x-axis here for a second, let's throw a 0 in here somewhere. -1, and let's see, 1, 2, and 3. And so if my intercepts are at -1 and 3, then they've got to be symmetrical, and so the number halfway in between would have to be the axis of symmetry, right? That would only make logical sense. So the axis of symmetry has got to be halfway between -1 and 3, which would be at 1. Now, there are several different ways to come up with that. I just did that by sketching a quick graph. The numbers don't always work out that nicely, though, and so we need a nice formal, I don't know, formula or process to be able to find that, even if the numbers are really nasty here. One technique is to just take the average. To find a number in the middle of 2 other numbers, the exact middle, you can take the average of those 2 numbers. Okay, so the average of -1 and 3, to find that, you just add the 2 numbers together and divide by the number of numbers. Right, that's how you take an average in general. So -1 plus 3, of course, is 2, and 2 over 2 is the 1, and that's the number we're looking for. Okay, so you can always find the axis of symmetry by using the average of the 2 x-intercepts. Okay, it's kind of a neat trick. So the axis of symmetry comes from this average. It will be x equals 1. Remember, it's a vertical line, so you got to have x equals a number. All right. Now, this poses a slight problem, however, because you don't always have x-intercepts. remember, you can have graphs that don't hit the x-axis, right? Things like if I had a graph, if this was my x-axis, I could have a parabola that's completely contained above the axis or below. That is a possibility. And so I may not have the intercepts in order to find the average. So there's got to be another way. And indeed there is. One thing I mentioned a moment ago is that you can find the x-intercepts by using the quadratic formula. I used factoring here, but the quadratic formula would have given us these two answers as well. Okay, the quadratic formula, however, if you think about that, it has two numbers that come out of it. If you look at the quadratic formula, it's negative b plus minus the square root of b squared minus 4ac all over 2a. This hopefully you remember at this point. But what's interesting is that one of the x-intercepts will come from the plus and the other one will come from the minus. If you were to average those, if you were to average the two values, then you'd be taking the quadratic formula of the plus and adding it to the quadratic formula of the minus and then dividing by 2. Okay, so you'd have something very nasty looking. It'd be like negative b plus the root, I'm not even going to write the whole thing out just to save some space here, all over 2a. And then you would add to that negative b minus the root all over 2a. Right, so this quadratic formula with the plus, quadratic formula with the minus, those give you the two x-intercepts. If you add them up and divide the whole thing by 2, you end up with the axis of symmetry number. Okay, now what's cool about doing this is that when you go through and simplify, there are two things that drop out very, very conveniently. This square root over 2a, right, that thing over 2a is a plus root over 2a. This one here is a minus root over 2a. The two together add up to 0 and are unneeded. And so the average really simplifies down to negative b over 2a, that's this first term, plus negative b over 2a all over 2. And if I combine those, I have two of the same thing on top. I could call that 2 times negative b over 2a, right? Two of the same thing added together all over this 2. The 2's here cancel and you're just left with negative b over 2a. This is the general formula, that's why I'm using the green pen again. This is the general formula for the axis of symmetry and therefore also for the vertex. Because if you look at the original example here, if I use that formula, if I take x equals negative b over 2a, the b was negative 2, so it would be a negative of negative 2 all over 2 times a, which is 1. Double negative cancels, you get 2 over 2, which is 1. Okay, so we got our 1, which is the same thing we got before. So all these things, you know, they're consistent. They give you the same result. Okay, so as a general rule, to find the axis of symmetry, there are two different methods. One is you can average the x-intercepts. The other is that you can use this formula, negative b over 2a. The formula is nice because it works every time, even when there's no x-intercepts. But averaging the x-intercepts can be nice when the numbers are nice, and there are two of them. Okay. Okay, now for the vertex. Well, the vertex will share the same x value as the axis of symmetry because the vertex has to land on the line on the axis of symmetry somewhere. And so I know that the x value is 1. To find the y value, I need to take that 1 and plug it back into the original function. Okay, so the vertex, the first part is 1, the second part is going to be f of 1, which is, let's see, 1 squared minus 2 times 1 minus 3. That's going to be 1 minus 2 minus 3, which is, let's see, negative 1 minus 3 is negative 4. Yep. And so I know that my vertex is going to be the point 1, comma, negative 4. All right. So I can get the vertex again from the same formula, negative b over 2a. And then by plugging that number in, I can get the y coordinate. All right, so that gives me the vertex. In our list now, the only things missing are the points symmetric to the y-intercept and the domain and range. So let's look at the point symmetric. And again, I'm abbreviating quite a few things here. Whoop, point symmetric to y-intercept. I'm abbreviating those. Now, to find that, remember the y-intercept, wherever that ends up, it's going to be at 0 here somewhere. Wherever that ends up, the symmetric point is going to be at the same height, but an equal distance. You can't really see that. The y-intercept is on the y-axis here at 0. Wherever that ends up, it's going to have a symmetric point in equal distance on the other side of the axis of symmetry. But it's going to have the same height, right? It's just going straight across. So I know that the point symmetric is going to have a y value that is equivalent to the y-intercept, which I found way at the beginning was negative 3. So that negative 3 is going to come down here. Okay. And then the x value is going to be, well, double the axis of symmetry, right? If it's got to go over to the axis of symmetry and then over again the same amount, right? Over to the axis, over the same amount. So double the axis of symmetry. Well, 2 times the value of 1 is 2, so 2 would be the symmetric point. Okay. So as a general rule, your symmetric point here is going to be double the axis of symmetry value, which is 2 times the negative b over 2a, and then it's going to be your c for the y value. Okay, that's the height of the y-intercept. All right, finally, the domain and range we can get off of this as well. The domain, first of all, is always all real numbers. And the range, well, because this graph opens up, it's going to have a minimum value at the vertex. In our case, negative 4. So negative 4 is the lowest this graph goes, and then it goes up from there. So the range will be negative 4 to infinity. Okay. All right, in the next video, we'll put all this together and sketch the graph.